Welcome back to the week 5 lecture. This is the second part of the video installment. So let's take a look at a new example to continue on from what we were doing before. Suppose x is a particular real number. Let p, q, and r symbolize following statements respectively. Let's rewrite these symbolically. All right. So if x is less than or equal to 3, remember that this is x is less than 3 or x is equal to 3. So from that, we can take, this is our P, Q, and R. We can rewrite this as what exactly? This would be Q disjunction R. Then if we have an example, 0 is between, so 0 is less than x, which is less than 3. This is the same thing as saying 0 is less than x, and it is also less than 3. Now the way we would write this, we have P conjunction Q. Now here's where it gets a little bit trickier. This is one of those multi-ways to write problems. If we have 0 less than x less than or equal to 3, that's 0 less than x, and x is going to be what exactly? X is less than 3, or x is, so we have x less than 3, or x equal 3. However, the trick here is since it's less than or equal and it is still a bound, we must have parentheses around this. So this would equate to P and is our conjunction, and then we have parentheses Q disjunction R. Oops, that looks kind of like a mess. Let's try and make them so one looks like a V and your letters don't get mixed up like mine do. There we go, much better. So to continue here, we start with truth tables. Let's dive right in. If P is a statement variable, the negation of P is not P, which we talked about previously. So assume P is our true statement, leaving not P to be false. So to fill in a truth table, you'll always have your true, and we just said that not P is false. However, what would have happened if what would have happened if P wasn't true to begin with, but it was false? Well, if not P is the negation of that, the negation of false gives us back a true statement. When we work with truth tables, we always write out all possibilities of true and false combinations based on the given statement variable. For example, here we only had P, therefore we only had true and false. Now we can also make a truth table for conjunction. This one's going to be a little bit different. When we're working with conjunction, we now have to have two variables here. So we'll start this off by true, true, false, false, and then we'll alternate our other possibilities. Our goal here, and this will always be our setup for two variables, our goal here is to end up with all possible combinations of these two things. Now, we have our true, 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 false, false, true, and false, false. Conjunction. In order for conjunction to be true, both variables must be true to begin with. So our only true conjunction is the true, true conjunction. If one is true and one is false, we'll think of that like our intersection of two completely disjoint sets, right? So that would be something like this. They have no intersection. And that looks like some crazy face, so let's put ears on it. Anyway, despite that, if we have true, false, well, that's going to be false. False, true, still false. And of course, false, false, if nothing's true to begin with, then the intersection still has to be false. So to keep going, we have some more examples. What about the truth table for disjunction here? So we're going to start off the same way with our P and Q values. So we have our true, true, false, false setup, and then our true, false, true, false. For this, only one of them has to be true. So in this first case, we have true or true, still true. True or false, again, is still true. False, true, true, and false, false. Since false, false had no true statements to begin with, this would also still be a false statement. Now, along with this, make note of this crazy table we have below. Let's prove a statement here. What we're going to show is that P disjunction Q, conjunction not P conjunction Q, let's see what we get for that. Let's see what our actual values are. So again, we start off, and I will pause the video for time and fill this in. Alright, so to pick back up with this, I've already filled in what we've done above. So we have the not P conjunction Q, which comes from this portion over here. Now this is going to be the negation of everything in this column. So it's going to be false, true, true, true. And now we want to take both, and I'll put this in a different color. We need to look at P disjunction and then our not column. So we need to compare those values in order via our conjunction in order to see what we're going to get. So now we have true, false, still with a conjunction that's still false. True, true, which is true. True, true again, which is also true. Then false, true, which is still false. So note here that this would give us all possibilities of truth within whatever we're doing. Sometimes it doesn't necessarily seem relevant, but when you're working with English statements and converting back and forth, this might give you all possible outcomes of a certain something or other, which we'll see as we work through more of these. So these can definitely get a little bit more complicated, but usually nothing too crazy. Typically, you'll have 2 or 3 things. The most common is 2, however, we can have now something like PQR. And usually you'll have this first, so I guess what I can speak for is in our class, I will always fill in the first portion of it, so this way everything else should match up. As far as your columns go, if we have P, Q, and R, and we need a not R, you could either do not R next, or you could do the P conjunction Q. It doesn't really matter which. But as you work through these, you'll get more comfortable with what to put where. Usually we just put the not a variable next to wherever it's located, just to keep things simple. But then lastly here, we're going to have P conjunction Q, disjunction not R. So bear with me as I try and squeeze that in there. I'm going to go ahead and fill this table in for time, and then we will get back to doing the rest together. Notice here upon filling in the table, it's very similar to the pattern that we used for the P and Q table. We always start off with for P, the trues blocked together and the falses blocked together, and then Q is always going to alternate in smaller blocks. So if we have 2 things here, well, how many do we have total? So we have 3 possibilities. That equates to 8 different ways we can assort these. Think of that 2 to the n rule that we have. So that tells us how many of our rows we'll have. Along with this, so you'll have 4 and 4, 2, 2, 2, 2, and then everything will alternate for R, and this will always be the case. Along with what we had done before, not R, we just switch all of our values backwards from what we had R as. Alright, now with that P conjunction Q, well, this is going to be this is where it gets a little tricky because we have so much going on in the column. So we will have true, true, false, 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 and everything else is false. Now, if we're going to take this next piece, so this is where everything gets a little bit hectic. P conjunction Q is this column here, and then we want to disjunction that with not are, which we have there. So if we put these two things together, well, let's see, we have false, true. Only one of them has to be true. So it's true, true, false, true, false, true, false, true. With these, sometimes you'll see a pattern, not always. It really depends on the question. The more complicated they get, then you'll notice different things happening with them.